Now, in this video, we are going to take up one more problem on elastic constants. So the problem reads as problem number 66. Determine the changes in length, width, and thickness of a steel bar which is 4 meter long, 30 mm wide, and 20 mm thick, and is subjected to an axial pull of 30 kilonewton in the direction of length. E is 2 into 10 to the power of 5 Newton per mm square, and Poisson's ratio is 0.3. Also, determine the volumetric strain, change in volume, and final volume of the given bar. So how to proceed with this particular problem? So he has given the length of the bar, which is 4 into 10 to the power of 3, which is 4 meters converted into mm. Then wide is 30 mm, so B is 30 mm, and D is 20 mm thick. So axial pull is 30 kilonewton, that is 30 into 10 to the power of 3 Newton in the direction of length, that is along the x-axis. So to find out the volumetric strain, change in volumetric strain is epsilon V, change in volume is delta V, and the final volume of the given bar. So first we will take up the data. Length is 4 meters, 4000 mm. So B is to be 30 mm and D is 20 mm. And then Young's modulus is 2 into 10 to the power of 5 Newton per mm square. And then P 30 kilonewton, which is 30 into 10 to the power of 3. So 1 by m, that is the Poisson's ratio, which is 0.3. So what are all the change in dimensions? First we need to check. So since we know the length, so here first we are going to find out the cross-sectional area. So what is the cross-sectional area? As the load is applied along the length, so naturally the cross-sectional area will going to become width and thickness. So the width and thickness is 30 mm wide and 20 mm thick. So that will be 30 into 20. So it will be 600 mm square. Then what is the change in length, which is delta L, which will be equal to P into L by A into E. So what is P? 30 kilonewton. So 30 into 10 to the power of 3 into length is 4 into 10 to the power of 3 divided by area or cross-sectional area is 30 into 20, which is 600, into Young's modulus is 2 into 10 to the power of 5 or 200 into 10 to the power of 3. So on simplification, once you calculate these values, you will going to get the value as 1 mm. Since it is the load is applied along the direction of length, so naturally it should be tensile. So since it is a tensile force, so naturally there will be increase in length. So that is the reason why he says it is increase in length. So what is the longitudinal strain? Longitudinal strain epsilon x will be equal to delta L by L. So what is delta L? Delta L is nothing but 1 mm divided by length of the member is 4000. So which will be equal to 0.25 into 10 to the power of minus 3. Once you get the longitudinal strain, we can get the lateral strain. How? We know that the Poisson's ratio is 1 by m, which is epsilon lateral by epsilon longitudinal. So we want the epsilon lateral, so 1 by m into epsilon longitudinal. So what is 1 by m? That is the Poisson's ratio, which is 0.3 multiplied by epsilon longitudinal is the longitudinal strain, which is 0.25 into 10 to the power of minus 3. On simplification, you will going to get it as 0.75 into 10 to the power of minus 4. Since it is a lateral strain, so naturally you will going to have unitless or dimensionless. Next, we have the change in width. What is delta B? Delta B, since it is the width is the lateral dimension, so the lateral strain into B. So that is lateral strain is 0.75 into 10 to the power of minus 4 into B. So what is that value? 0.75 into 10 to the power of minus 4 into 30. B value is 30. You substitute this value. By using the calculation, you will going to get it as 2.25 into 10 to the power of minus 3. As the load is applied along the length, so naturally what happens, the lateral strain or lateral dimension will going to be decreased. So therefore, you will going to get the decrease in width. Similarly, you will going to get the change in depth of the thickness, which is delta D, which is epsilon lateral will be equal to delta D by D. So since we want the delta D, so you will going to multiply epsilon lateral into D. So that is again 0.75 into 10 to the power of minus 4, which is epsilon lateral, into D, that is the depth or thickness. You know the value of D, which is 0.75 into 10 to the power of minus 4 into 20. On calculation, by calculating these values, you will going to get it as 15 into 10 to the power of minus 3 mm. So that will be is nothing but there will going to be a decrease in thickness also. So these are all the change in dimensions. So then what we need to find out? We need to find out what is the volumetric strain. So how to find out the volumetric strain? Epsilon V will be equal to sigma by E into 1 minus 2 by m. What is sigma? That is the stress V. Epsilon x. Sigma by E is nothing but epsilon x, that is the longitudinal strain, into 1 minus 2 by m. What is epsilon x? Epsilon x is nothing but 0.25 into 10 to the power of minus 3 into 1 minus 2. 1 by m is nothing but 0.3 into 2. So you will go on calculation, on simplification, you will going to get this value as 10 to the power of minus 4. So since it is a volumetric strain, so you will going to have the unit as. Then what is the virginal volume? Virginal volume V will be equal to L into B into D, that is the length into breadth into thickness. So 4000 into 30 into 20, which will going to be 24 into 10 to the power of 5 mm cube. So we have the final volume. So see, we know what is epsilon V, that is the volumetric strain, which is change in volume by the virginal volume. So you know the volume, change in volume, delta V, we know to find out what is delta V. So delta V, your volumetric strain, which will be 10 to the power of minus 4, will be equal to delta V by V, which is 24 into 10 to the power of 5. How do I know the volumetric strain? Epsilon V will be equal to, on this sigma by E into 1 minus 2 by m. So you have got this as 10 to the power of minus 4. So 10 to the power of minus 4 is equal to change in volume, that is delta V by V. We don't know the value. We don't know the value of delta V, but we know the virginal volume is 24 into 10 to the power of 5. Substituting these values, you will going to get the delta V, that is the change in volume, is 240 mm cube, which is finally there will going to be an increase in volume. So this is how you will be able to find out the volumetric strain and also the changing dimensions. Thank you.